Okay, let's look at an example of how to calculate a p-chart from a series of samples taken over time. And as you can see, this is from problem 7.2, and it's from um, Schuert's classical book called Economic Control of Quality of Manufactured Product. And it's apparently they have inspected many machines over a year and found some of them to be defective. So what I'm assuming is that they're wanting to come up with a better maintenance schedule perhaps for the machinery that they're inspecting so that they don't have defective machines. Looks like the month of May was a particularly bad month. So we're going to use the formulas over here that were found in the book and also on this slide content for this week. And we are going to use these first two for calculating the upper and lower control limits because we're going to do a simple p-chart. And why is that? Because there are varying sample sizes across the months. So we need to do a proportion as opposed to counts, as we talked about. Very important differentiation there. So first of all, we're going to do just a simple calculation of the percentages of machines that are defective each month. And we do that just by taking the number that are defective and dividing it by the number that were inspected, and we get 0.76%, so not too many, and then less than 1%. And then we can just copy that down and get the average, and we can copy this again. I am not sure if we're going to need the overall. Nope, it's not going to work. There's nothing there. So we need to first calculate the average so we can use that formula. And as you know, we can go up to recently used formulas and click on average, and then drag our cursor across the data that we want averaged, and that gives us 5.25 machines a month on average were defective. And then we want to do the same for this, and then we see our overall average then is 1.09, which is also the p-bar value. So hold that thought. We also need the totals, and again we can look at recently used and to get the sum. We also can do this auto sum, which is kind of fun, but the auto sum will do the whole column. We can do it either way. And then again we want these same numbers. So there was a total of 63 defective machines over the year. And then we can copy this across, and there's a total of 5,900 or 797 machines. Okay, now I said that this overall average of percentages is the p-bar value, and we can check that by dividing the total defective ones by the grand total of the number that were inspected, and that's 1.09%. So those are the same values, and that is a good thing. Okay, we are ready to calculate the upper and lower control limits. So we're going to do this formula by hand, and the formula is, do an equal sign, it's going to be this p-bar value plus 3, and then we're going to multiply it by the square root of a bunch of numbers. So we will do a multiplication sign, and I happen to know what the formula prompt is for square root, but if you didn't know, you could go up here and look at the math formulas and go down, and there it is, SQRT. Now, I'm not going to click on that because I want to just put it in by hand, but you could, and it would prompt you with a box and walk you through how to do that. But I think since we're inserting it in the middle of a formula, as opposed to just doing a square root, it's easier. See, it's going to let me tell me what it is when I start to type it. I think it's easier to type it in. So that's me. So the square root of, and it's good to put what you want the square root of in parentheses. So we want the square root of again, the p-bar number we see over here. Here's our formula. P-bar times, and then let's put another set of parentheses here. It'll be 1 minus the p-bar number, and then we can put parentheses around that, and then we are going to divide it by the average number of the overall n average. So it would be this number, not the complete total number, but the average number. So important differentiation there. And let's see, oh, it's telling me that something's wrong, and I know what's wrong. I did not put another parentheses on the very end. So yes, we'll accept that autocorrection, 2.5%. So that will be my upper control limit. And then if I want to be lazy about this, although if I was going to be lazy, I'd need to have the same numbers here. So I need, well, I'm trying to decide if I should put in the dollar signs or just copy it down. Now it's going to give me a different number. So now I've got to fix it. So instead of plus, this has to be a minus. Okay, so you've got to keep straight now what it is you need to go back and fix. Because I didn't put dollar signs around to use the same cell. So we know that the p-bar is B21, so I'm going to need to change that across here. So it's because it's saying B22, so let's put ones for all of those. And then this is also not right. It should be C19, so I need to change that number as well. And let's see what I get. So since it's below 0, what you want to do is just make that a 0, because we're not going to have a negative number of defective machines. That makes sense. We're just going to have 0. So we'll make that a 0. I'm going to put it over to the side here, though, just so I remember that I'm changing that number. Okay, so you notice that again, I've got what I want in the graph lined up here, so it just makes it very easy. So my p-bar value is this, and I want it to remain the same all the way across for the upper and lower control limits. So I'm going to put dollar signs there, and then I'm going to copy that all the way down. So that's my p, then the middle value, and then the upper control limit, I want that to remain the same too, right? So there it is, 2.5%. And again, I'm going to put dollar signs on either side. And then I'm going to copy that all the way down. I want it to be the same value. And this is easy. I just want that to equal 0. Now I could reference this cell down here, but I'm just going to say 0, and that'll make it really easy. Copy it all the way down. So now I have got the makings of my graph. So let's copy all of this, or not copy it, but highlight it. That's what I want in my graph. Insert a line graph. Just a simple line graph will do. And there it is. So what can we tell from this? That we've definitely got some outliers, don't we? We've got, and And what was going on? We already kind of knew that from looking at the data, that that those months of May and October, and they correspond to the numbers down here. 5 is month of May, are out of whack. So what was going on in that month? We basically just need to go back and do a little sleuthing to find out. And if I had more time, I would make another graph for machine B and do some comparisons to see if that gives me any more information. So that's all there is to it. I think it's a bit simpler and more intuitive than the XBAR graphs in a way.